Hey y'all, I got a couple emails about the last two questions on the practice sheet from Law of Exponents Day 2. So I was going to make a problem that was similar of each. So let's start with this one. So let's say we had, get my pen. Let's say we had x into, let's say we had y negative 4 times, let's say we have 4x negative 4 y negative 2 times I don't know, let's say 10x 3 y 4. So as you can see, we are multiplying monomials, right? Because you see the little dots here. So that means we're multiplying. So remember with the multiplying rule, right? So when we're multiplying, we multiply coefficients, which is the big numbers. So boom and boom. And then we know there's an imaginary one if you want to think of it being there. And then we add exponents. So I think the multiplying part y'all are pretty good with. So like 1 times 4 is 4. 4 times 10 is 40. So I already know that my front coefficient is going to be 40. Now, with our exponents, remember we only add the exponents of the ones that have the same base. So like here's my x squared term. So I'm going to have 2. Here's my x negative 4. So I'm going to have a negative 4 added to that. And then here's my x to the third. So I add that. So all three of these numbers, when I add them, so I'm going to add 2 plus negative 4 will give me negative 2. And then negative 2 plus 3 will give me a positive 1. So x to the 1. Or if you just want to put x, that is fine. But we also have to remember that we're going to do the same for our y exponents. So negative 4, negative 2, y4. We are still adding the exponents together. So for this one, we have negative 4 plus negative 2 plus 4. So that negative 4 and negative 2 will give us negative 6. We add 4, and that's how we get negative 2. Now, the only issue with this problem, though, is y'all just learned about negative exponents. We are not allowed to have a negative exponent in our final answer. So all that is going to do is going to shift it. So this is my negative exponent. So that will move, but my 40 will stay the same. My x to the fourth will stay the same. And then once I move my y, it is now a positive. So once you move it, that negative disappears. Think of it like if an elevator button, if I'm going from floor 1 to floor 2 or from floor 2 to floor 1, once I reach that level, that button right here that's being pressed is no longer pressed anymore. And this will be our final answer. I'm going to go ahead and fit the other problem, which was like the very last one. And actually, I might just scroll down. Let's do that. All right, and so let me make up a problem. So for this one, it did involve some division. So let's do 8 x y negative 4 all over, let's do 16. Let's do x negative 5, and let's do y 2. So here, easy thing to remember, anytime you have a fraction bar, that is division. So we are dividing monomials, right? So fraction means division. And remember that division rule is that we divide our coefficients, and then we're going to subtract exponents. So when I look at my front coefficients here, so I'm going to do that in black. So I'm going to look at these right here, and I divide those. It actually does not divide into a whole number. It will simply reduce. So I can divide the top by 8, and I can divide this bottom by 8. And so when I do that, I end up with 1/2. I'm going to make it long. And so now I'm going to look at my exponents, and I'm going to subtract them. I'm going to go ahead and put my x here because I'm going to be dealing with my x's. Remember, if there is no exponent, there's an imaginary 1. And so we're going to end up with 1 minus negative 5. Again, all I took was my exponents, and I'm subtracting top minus bottom. Anytime we have a double negative, it's like we're adding, so we get 6. So we get x to the 6. Now I'm going to go to my y. So we have y negative 4, and we have y squared. So we end up with the top number minus my bottom number. And for this one, we get negative 6. Whenever we do our subtraction, we're just going to start from the numerator. And then I'm going to put that value. Now, once we have completely done our division rule for our monomials, now we can worry about our negative exponent. So here's negative 6. It's going to come down. So we end up with 1/2. That y6 came down. And this x to the 6 stays in the same spot. So the only thing that moved was our negative exponent, which was negative 6. And then this would be our answer. Sometimes you might see it written as x6, 2y to the 6, because it's understood to be imaginary 1 there. I really hope this helps with those last 2 problems that you may have had. Feel free to continue sending emails if you have questions, and we'll go from there. Y'all have a great one.